Hi everyone and welcome to this video tutorial. Today, I'll walk you through the steps on how to implement EtherChannel on Cisco Packet Tracer.
But first, what is EtherChannel? EtherChannel is a technique that combines multiple physical links between switches into a single logical link. This helps increase bandwidth, improve redundancy, and avoid loops, especially useful when working with Spanning Tree Protocol or STP. As you may notice, the setup looks familiar, and you are right. It builds on what we did in our previous video about Spanning Tree Protocol. However, I've added 2 more switches and 3 additional PCs. Each of these new PCs is assigned to VLANs 2, 3, and 4. You'll also notice that some labels appear next to the cables, which are LACP, PAgP, and ON. So, what are these LACP, PAgP, and ON? These are Ether-channel negotiation protocols. LACP or Link Aggregation Control Protocol is an open standard used to negotiate Ether-channel connections. Meanwhile, PAgP or Port Aggregation Protocol is a Cisco proprietary protocol similar to LACP. And lastly, ON or manual is the Ether channel that is enabled manually with no negotiation. Let's begin by configuring LACP. Start by going to the CLI of the first switch. Before you configure anything, identify the trunk ports that connect the switches. Now, to implement LACP, you'll need to understand mode combinations. For LACP, use mode active or passive. At least one side must be set to active for negotiation to happen. For PAgP, use mode desirable or auto. At least one side must be desirable for the channel to form. And for ON, both sides must be set to on, and there's no negotiation. It forces the channel to form. After grouping interfaces into a channel group, you can access that group using the interface port channel command. What is interface port channel for? This command lets you configure settings that apply to the entire Ether channel group, like trunking or VLAN assignments, instead of setting them individually on each physical interface. Once you've configured the Ether channel group, verify it using the command show Ether channel summary. This shows whether the Ether channel was successfully established and what mode it is using. Now go to the second switch and repeat the same LACP configuration. Just be mindful of the ports. Make sure you're configuring the correct interfaces that connect to the first switch. And on the third switch, don't forget to repeat the LACP configuration to ensure it properly connects to the second switch. Next, let's configure PAgP between the third switch and the fourth switch. This time, instead of LACP's active mode, we'll use desirable for PAgP. This situation highlights how important it is for the ports connecting two devices to have matching negotiation modes, or otherwise, the Ether channel will fail to form a connection and the link won't function as expected. To solve the problem, we need to use channel group 3 instead of channel group 2. After that, apply the same concept on the fourth and fifth switch. For switches 3 and 5, we'll use the on mode for Ether channel. To make sure everything's working correctly, try pinging across pieces that are connected to the different switches. As we can see, the ping is successful, which confirms our EtherChannel configuration is correct. And that's it for this tutorial. Thank you for watching.